Alright, today in this video I'm going to be explaining and showing you how OSPF and EIGRP notify their neighbor of a downed directly connected network. So I just have a simple topology here, R1 directly connected to R2, and I'm going to simulate loopbacks as networks, and then I'm going to do a Wireshark packet capture to see what is actually being sent out and how do they notify their neighbors about this down network. Uh, EIGRP uses a query message, and in that message, there'll be the network that is down, and it'll advertise it as an infinite metric. So the uh, receiving router, when they get that query message, they'll say, okay, well, now I got this infinite metric, and I need to reply to this query to see if I have another path. So that's how EIGRP does it. OSPF, since they already have knowledge of the entire network, unlike distance vector protocols like EIGRP, OSPF already knows who's directly connected to it. So he's just going to update an LSA, update the sequence number, and just not include that network. Okay? So EIGRP is already running. Once I demonstrate EIGRP, then I'll switch over, configure OSPF real quick, and then I'll do the packet capture. So let's get into it. Bring up R1. And just do a few quick show commands so you can see what's running. So I'll do show. We'll do a show IP route. And I got one EIGRP link, 2222, which is the loopback on router 2. Show IP EIGRP interface. So I'm running EIGRP on fast Ethernet 00 and loopback 1. And if I go to R2 real quick, alright, so let's see what's going on here. Show IP route. If I can spell it right. Show IP route. Alright, everything looks good to go. Everything's good. So let's start this Wireshark. Start capture. And we'll look at it from R2's interface. Start that up. Kind of shrink this so we can see it. And I am going to filter based on this protocol right here. Right click, apply filter, selected. So I only see EIGRP stuff. Sweet. Alright. R1 now. Fig T, interface, loopback 1. Shut it down. Boom. I already got that query, reply. Alright, that's good to go. Let's stop that and let's expand this. Let's double click that. And what's going on here? And expand this here. Now this infinite metric, I've seen some. Why don't you expand? There you go. Maybe we don't need to see all this stuff, but I want to expand everything here. I've seen some shots, some Wireshark shots, where it will actually show you right here. It'll say, I believe it'll say something like route unreachable, but in this capture, what's happening with my pen? Route unreachable, or unreachable route, something like that. But this one doesn't say it, and what actually tells the neighboring router, and this is the query message that R1 sent out, that that network is down, is right there. When you set the delay to that number, I think that's 4,294,967,295, which is basically all 32 bits turned on, if they're all set to 1, right? That means that the destination is unreachable. So that's how EIGRP will tell its neighbors that this network is down, and do you have another route? Okay. So that is EIGRP. Yeah, so, right, with every query message, there has to be a hello packet to acknowledge it, and then once R2 realizes that he doesn't have a better route, then he has to send back a reply, also saying that, nope, I don't have another route. Sorry, guy. And maximum metric. So that is EIGRP. Uh, I mean, I don't want to say that it's simple, but it kind of is. When a network is down, tell the neighbor, query him first and say, hey, I got this network. Here's the infinite metric. Do you have a better route? And then the other guy's going to reply. OSPF, a little bit different, not too much. Let me configure this real quick, OSPF. Oh, let's get rid of EIGRP. No router EIGRP1. I believe that's it. Do the same thing here. No router EIGRP1. Do show run begin router. Nope. Of course, it's not going to work. Router. Good. So there's no EIGRP. So let's do OSPF. Router OSPF 1. Router ID 2.2.2.2. And I'm going to go into the interface and turn it on rather than doing the network statements. So interface loopback 1, IP OSPF 1, area 0, IP OSPF network, point to point. Now go into F0/0, do the same thing. And then R1, router OSPF 1. Router ID 1.1.1.1, interface loopback 1, IP OSPF 1, area 0, IP OSPF network, point to point. Good. Rinse and repeat. Neighbor relationship. There we go. And show IP route. Got some O's. Once it comes up. Oh, I didn't shut it down. Or I didn't bring it back up. Interface. Okay, there we go. And R2. Do you show IP route? It sees R1. Okay. Actually, let me bring R1 down first, or loopback 1 down first. And I'll bring it up when I do the packet capture, and you'll see the sequence number when R1 tells R2 about it. Then I'll shut it down, and we'll see the new sequence number with the route missing. Alright, so that's what I'm going to do. Double check this. No OSPF route, sweet. Let's do it. Stop that old capture. Let's start a new one. R2. And again, let's only look at OSPF stuff. Okay. And R1, no shut. Bam. Got the LS update, told its neighbor, got an acknowledgement, and R2 should be seeing the loopback. And it does. Sweet. So actually, let me open this up, save that. Now let's do a shutdown. And let's look at both of these wire captures. Shut. Ooh, another update. Sweet. As expected. And another acknowledgement as expected. Okay. Let's bring these up. Let's look at it side by side. I don't need Wireshark on anymore, so I'm just going to stop that. And let's look at this. So this one was the new update with the down network. So let me put that to the side real quick. Then this is the one where R1 told them about this. Open this up. Open up. So this is a type 1 LSA, so it's a router LSA. And here's all the information about it. Point to point, two stub networks. This right there is the loopback of R1. Told him about it, told him what the metric is. All good stuff, right? Okay, so that was when I did the no shut, brought it up. Sequence number ends with a 06. Okay, well, once I did a shutdown, there was a new LS update. And let's look at that sequence number. Look at that. It updated by 1. So what OSPF is saying is, all right, you got an LSA from me. The sequence number was 06. That was my latest and greatest information. Bam. But then something happened to my network. Oh no. I need to send out a new LSA to tell everybody, hey, that network is down. And when I do that and I send out my new LSA, I'm going to increment it. So everyone needs to be on the same page of my sequence number. And inside of that is the, again, type 1 LSA, because there's the router. Scroll down, that network is gone. Okay, do a side-by-side comparison. One had the 1111 network, the other one didn't. So, if we go back to R2, hit the up arrow, it should not be there. And do show IP OSPF database. I probably got to look at router. And for router 1, there's a link state, there's a router. There it is. Number of links, 2. Look at that sequence number, 7. That is exactly what we caught here. So whether we see it in the OSPF database or we do it with a packet capture, we could still see the same thing. But I did a side-by-side comparison. So that is how OSPF and EIGRP advertise to their neighbor about a downed network. I noticed, like, I've studied EIGRP and OSPF before, but now I'm like getting into the nitty gritty of things, and it's really blowing my mind. And some of these things, it's hard to find. Like, if you just look up EIGRP, little query messages, there's a lot of like vague information out there, and they'll say like, oh, query messages is just to notify a neighbor of a down network, and and ask the neighbor if they have a better path, you know, better path. But how does he actually tell the neighbor that it's down? And that's where I was like, I need to know. And it's about that infinite metric, and it does it in the delay. Roughly, it's all 32 bits turned on, so it's almost 4.3 billion. And then with OSPF, all they do is update the LSA with the new sequence number, and then don't have the network in the LSA. So that's how EIGRP and OSPF tell their neighbor about a down network. I hope this was informative for you, and I'd like to thank you for viewing.